Okay, welcome to Slopes of Parallel and Perpendicular Lines. As we try to move on through our segment on linear functions, we want to talk about here just some elements, just a few elements of slope of parallel lines prior to moving on to perpendicular line. So quickly, our objective here is to identify and graph parallel lines. And we also want to write equations to describe lines that are parallel. Why do we want to learn this? Well, primarily we can do it to model cost, such as like if we want to compare cost for cell phone plans, or like I told you when I wanted to take a look at um, what I was paying at a membership for um, health membership. I decided to either pay some money down or no money down, and see which payment plan was the cheapest over a year period of time. So these parallel and perpendicular lines is a very useful tool for us. So we might as well just go ahead and understand how it relates to linear functions. So what I have here is just two sets of lines. The first set is actually parallel. If you look, the lines are going at a segment where they're not going to meet anywhere. So that's pretty much what we look at when we look at the definitions of a parallel line. There are two different non-vertical lines, and we say that they're parallel if and only if they have the same slope. So when we talk about slope again, we're talking about when we're looking at y is equal to mx plus b, and actually this slope is always going to be, your slope is always going to be your actual constant, or your number in front of the x. It's a good way to explain it. So here we have a slope of 3, and we look at the bottom line, it also has a slope of 3. The only difference that set these two lines apart is one has a y-intercept of a +5 or +5, and the other has a y-intercept of a -5. So these lines will run in conjunction with each other and never ever meet. So we say that these parallel lines are lines in the same plane. They're coplanar, they're in the same plane, but they do not intersect. These in this particular example here, these are two non-vertical lines. Then this little example that I put for us here on the bottom let us know that all different vertical lines are parallel. We can estimate this as being x is 5, and the line is going to run parallel with the y-axis, and x is a -5, and it's going to run parallel here with the y-axis. But these lines again, they will never ever meet. So if we can keep that in mind as we work through these problems, it will be pretty easy. It'll be pretty easy to be able to identify if two lines are parallel, and we'll come to perpendicular a little bit later. So on with this, let's go to the next section and work some problems. See you there.